In this video, I'm going to show a complete solution to a systems and an equation internal. This one's called the curry restaurant. You can find a complete set of slides to go with this through the link in the description below. So a restaurant needs to buy meat for its curries, and the meat is either beef, lamb or chicken, and it comes in different prices per kilo. The restaurant needs a total of 45 kg of meat, and it's got $370 to spend. But the amount of meat it requires on a weekend day is different to a weekday. So at the weekend, twice the amount of beef plus 4 times the amount of lamb is 65 kgs. During the week, 3 times the amount of beef is 35 kgs less than 4 times the amount of chicken. And there are two situations that we're going to look at. We need to advise the restaurant on its meat orders for the weekend and during the week. So the first thing you should always do is define the variables. And I've defined X for the amount of beef, Y for the amount of lamb, and Z for the amount of chicken. But I really should have included the amount of beef in kilograms, lamb in kilograms, and chicken in kilograms. You really should include the units if there are units present. So let's go for the weekend situation, and the first thing we've got to do is define our equations, or produce our equations. And I think it's really important that what you do in these cases is that you put a label for each equation. So the first equation is the amount of meat, and we knew there were 45 kgs, and I put x plus y plus z is 45. The next one's money spent, so it's 12x because it's $12 for each kilogram, plus 9y plus 5z is that total of $370. And then the last one's a relationship one. It's really hard to put a title for that one, but it is given to us as a relationship, so that's what we use. And it was twice the amount of beef plus 4 times the amount of lamb is 65. So the first thing we always try and do is do these on the calculator, and when we do this one on the calculator, we do get a solution. So we get, when we do that, we get those values as 16, 8.25 and 20.75. It's important that we say that this is a consistent and unique solution. However, we've got to put this back in context, so we do need to put something along the lines of, so at the weekend they should get 16 kgs of beef, 8.25 kgs of lamb, and 20.75 kgs of chicken. Then we get the weekday equations. Well, the first two equations are exactly the same. The third one, though, is a relationship between chicken and beef, which said 3 times the amount of beef is 35 less than 4 times the amount of chicken, hence the equation 3. So when we try and solve this one, we don't get any answers, so there is no unique solution. Now, I like my last sentence here. We will interpret the equations as represented as planes in 3D, and that helps us look at the geometric representation that's going on. So, because there was no unique solution, there are several ways that the planes can be distributed. So the first thing I want to do is see if there are any parallel planes. And it says of the 3 equations, the ratios of the coefficients of any pair are not the same, so we have no parallel planes, because it takes the ratios of the coefficients have got to be the same for parallel planes. Since there are no parallel planes, we are left with only 2 possible cases. Case 1, the planes are inconsistent and produce a triangular prism. In case 2, the planes are consistent and meet along a line whose equation is the equation of the solution, and that's shown in red. So what do we next do? Well, we actually try and solve it by hand. You can see that equation 3 has no y. So what I'm going to do is use equation 1 and 2 to eliminate the y. So I'm going to do equation 2, take away 9 lots of equation 1. And that leaves me with 3x minus 4z is minus 35. And I'm calling that equation 4. If I rearrange equation 3, I get 3x minus 4z equals minus 35. And I'm calling that equation 5. When I subtract one from the other, I get 0 equals 0. Well, that is consistent with reality, so it implies that the situation is consistent. And we need to write down the solution is consistent but not unique, with the solution satisfying the intersection line. Okay, so the solution's on the intersection line, so we need to find the equation of that line. Now, On this one here, what we want to do is we already know that 3x equals 4z minus 35, and then what we want to do is substitute that into another equation. So I've multiplied equation 1 by 3 just so I can get the 3x's, and I've substituted that in to get 4z minus 35 plus 3y plus 3z equals 135. I could have changed that equation 3 into x equals 4z minus 35 over 3, substituted that in and solved from there instead, and I'd end up with the same result. Anyway, that gives me 3y plus 7z is 170, which if I rearrange for z gives me 170 minus 3y over 7. And then if I rearrange equation 3 for z, I make it 3x plus 35 over 4. What was important was I had two equations and they both had z in them, so I had to rearrange them both for z. So then I get my equation of the line, which is z equals 170 minus 3y over 7 from the first equation, but it also equals 3x plus 35 over 4. And the important thing about that line is that gives us the points that satisfy this will actually be solutions to our problem. We've also got to show that we understand that the answers are not unique, so we've got to find some possible solutions. Because we could have fractional answers in this, because you could have 0.3 of a kilo of meat and so on. I can put in any values, provided I get positive answers. It doesn't matter what you put in. I typically would find a value for x or y, but you could equally do it for z. Work it out for one and then find the corresponding value for the other. So on here we've got x equals 3, y is 31, z equals 11 as a solution, but I've got to put that in words again, so that could be, well, we say 3 kilograms of beef, 31 of lamb and 11 of chicken, and we've done the same again for 15 of beef, 10 of lamb and 20 of chicken. It's important that we do label these as possible solutions. If you can get all that done, get the correct wording done, and that's got the similar effect of the wording that I've used, then you should be getting an excellence in the end of your, when you get your results. I hope you found this helpful. Keep an infield with Winfield.